There are two networking terms which are regularly being used by consumers and business professionals: PoE and multi-gig. And so we thought it best to explain them a little bit. So this course is going to give you clarity on how these two chaps work and what they bring to the networking party. We'll begin with PoE. Power over Ethernet, or PoE, is a technology which allows a singular Ethernet cable to provide both power and network connectivity to PoE-enabled powered devices. Wireless access points, IP cameras, voice over IP or video phones, badge, keypad security door locks, and even LED lighting can all be powered and connected to the network through a PoE switch. And this takes away the need for a separate power supply and a power outlet close by. Power over Ethernet has added a wealth of benefits to consumers and businesses alike, such as lower infrastructure and installation costs, thanks to fewer power cables being required and only having to run one cable instead of two. PoE uses an existing IT networked infrastructure, so there's no need to explain to an electrician about having to wire in new sockets, effectively extending the wired and wireless network reach and overcoming the problem with hard to wire locations, such as ceilings for wireless access points or behind TV screens for AV extenders.
PoE is reliable too because it's the switch which powers the devices. An uninterruptible power supply co-located to the switch and router would keep the PoE devices operating in the event of power failure. This would maintain essential internet services to a building. A Power over Ethernet enabled managed switch can also offer centralized control of device power, allowing an administrator to manage the power to a device and, if necessary, reboot it, all without the need to even be on site. Power over Ethernet has been standardized by the Institute of Electrical and Electronics Engineers standard, or IEEE 802.3, since 2003. So, let's take a closer look at how the 802.3 standard has evolved. The original PoE standard, 802.3AF, provides 15.4 watts of power to an Ethernet port, which is used then to power a PoE device. This also recognises the fact that some power will dissipate over distance and therefore identifies that only around 12.95 watts of delivered power will be available over a 100 metre distance from the switch. 802.3AT, or PoE+, effectively doubles the PoE power by providing 30 watts to the Ethernet port used to power a PoE device, and therefore delivering 25.5 watts of power over a 100 metre distance from the switch, and this had a big impact on the type of device which would be implemented. It allowed for more sophisticated access points and security cameras to be utilised inside a PoE ecosystem, for example. Following the success of 802.2AF and 802.3AT, we now have a new kid on the block, 802.3BT, or PoE++, which comes in two distinct flavours, Type 3 and Type 4, and this allows us to carry up to 90 watts of electricity over a single Ethernet cable. This means we can power devices such as thermal imaging cameras, LED light fixtures and even larger screen displays. This is revolutionary to businesses across the globe because it's saving millions of dollars of infrastructure redevelopment. But wait, hold on a minute.
We do need to be a little bit careful though, because as we can see in this chart, there's a significant power difference between the two types of PoE++ being offered. At NETGEAR, we reference our equipment with a nomenclature of Ultra 60 and Ultra 90 respectively, making it clear as to which type is being provided. Now, some vendors might not be quite as transparent as that, so make sure you fully understand which type of PoE++ is being offered by the device first. As with all powered devices, standards are in place to protect PoE, and there are two types of PoE available, active and passive, with active PoE being ratified by the IEEE standards and passive PoE isn't. Active PoE provides 48 volts of power to 802.3 AF devices and 54 volts to 802.3 AT and BT devices. This ensures a safe voltage range with established communication procedures. Active PoE devices perform a handshake, which checks to make sure that the power is compatible between the PoE sender and the receiver. And only if the receiver acknowledges that the power is compatible will power then be delivered. Now, in comparison, passive PoE, these devices are vendor specific and they don't comply to the 802.3 standards. They don't perform a handshake. They'll just send the power regardless. And the power delivered could be anything from 24 volts upwards. There is nothing in place to determine how much power is being sent, and this can be really dangerous. It's extremely important to know what PoE voltage your device requires before plugging in the Ethernet cable and powering it up. Connecting the wrong voltage can permanently cause electrical damage to the device, and if you're not careful, it might start to cook.
More and more business owners are realising that they have outgrown 1 gig Ethernet and need something faster. The sheer volume of data being put on internal networks, like wireless devices, video, demanding applications, large file uploads and downloads, storage, backups, and even real-time communications, put an awful lot of stress on 1 gigabit Ethernet. While existing connections typically still work, Ethernet overload manifests itself as poor performance, such as slow, jittery video conferences, and file transfers taking a long time to complete, or worse still, time out and drop. The bottom line is that when 1 gigabit Ethernet is struggling to keep pace with demand, it has financial implications because it impacts on staff time and productivity, potentially even customer service levels too. The load on Ethernet is only going to increase as applications become more advanced and businesses becoming more dependent on virtualization and digitization. Plus, in the era of the IoT, the number of connected devices is going to explode. Now is the time to look at going beyond 1 gigabit Ethernet. So, if you have the decision to upgrade from 1 gigabit, it's important to consider all the options, because there's no one-size-fits-all solution. There are some straightforward decision-making factors that a business can use to determine the best Ethernet transition beyond 1 gig. The good news is that the process does not require deep technical expertise. A logical starting point is to look at how 10 gigabit and multi-gigabit differ from each other.
There are 5 different widely used Ethernet speeds in small and medium businesses, all universally defined by worldwide standards. 100 megabits per second, also known as fast Ethernet, and 1 gigabit per second or gigabit networks are widely deployed already. Beyond these, we have 2.5 gigabits per second and 5 gigabits per second. We refer to these as multi-gigabit or multi-gig networks. And after this, we have 10 gigabit per second or 10 gig Ethernet. What's critical to understand here is that it's not just a case of investing in faster Ethernet. Otherwise, subject to price, why not just go straight to 10 gigabit core Ethernet switches? For many businesses, there's a really strong case for doing that, but for others, there are arguments for choosing multi-gig. One of the biggest issues is that with 10 gig Ethernet, if network traffic is higher than 2.5 gig but less than 10 gig, dependent on the compatibility of the node, then the switch will downgrade to the nearest common denominator, 1 gig, meaning that the business will not be getting the performance that it's paying for. Pioneered by NETGEAR, 5-speed multi-gig supports all 5 Ethernet speeds from one switch. 100 meg per second, 1 gig, 2.5 gig, 5 gig and 10 gig, all from one switch. 5-speed intelligently auto-adapts ports to match the speed to the traffic, and users can create priorities, like video taking precedence over backups, for example. In practice, the result is that businesses can have Ethernet up to 5 times faster, right up to 5 gig, using the existing Cat5e cabling still found in many businesses today. NETGEAR Multi Gig immediately boosts a business's network speed and performance, ideal for demanding applications such as rapid file transfers, high bandwidth Wi-Fi connectivity and 4K streaming. Business benefits are faster, and there's better team collaboration, improved connectivity and even better communications with customers. Cabling is an important consideration too, because to perform beyond 5 meters, 10 gigabit Ethernet requires on-premise copper category 6A or fibre optic cables. So switching to 10 gig would mean replacing the existing cabling network, and depending on the size of the building or the number of users and devices, that might be an unnecessary expense or difficult to achieve in older buildings, even prohibited in some heritage locations. Don't forget to find out more about PoE and Multi Gig by heading over to the downloadable resources here in the course page, and we'll see you very soon.